Hello, my name is Sven Lieber from Ghent University, IDLab in Belgium. Let's have a small talk about constraints in RDF, expressed using so-called data shapes. But let me first ask you a question. Would you ride such a bike? Think about it. We go back to this example at the end of the presentation. By the way, this presentation we first going to talk about what constraints are, why we want to investigate the use of constraints, what we did to analyze them and how we did it, and what we actually found and what this means for you. So, what are constraints? When you want to represent real-world concepts in a machine-understandable knowledge model, you also have to deal with restrictions. So you might say that a bicycle has two wheels. Now, using a knowledge representation language, following the open world assumption, something like shown in this image is totally valid, because you defined your world that the bicycle has two wheels, and literally the second wheel is somewhere there in the world. But is this enough? Because we also want to use this knowledge representation. So if we slightly modify this restriction and say that a bicycle needs to have two wheels, we basically create a constraint which we can validate. So we basically close our world and only consider bikes of this particular image now and validate which bike has two wheels, has a certain color or a certain size, and other things. Okay, these are constraints, but why do we want to investigate the use of constraints? Well, the thing is that different constraint types exist. So, thinking about a knowledge graph with nodes and properties, you might want to constrain the cardinality of properties, or the data type of their values, or other more detailed restrictions on the values. But if you use now a tool to create and edit such constraints, we might run into a small problem there, because we can only use what the tool supports. But if a tool only supports what is commonly used, we run into this self-fulfilling prophecy, whereas we only use what's supported and nothing else, which is a problem. So what did we do to analyze it and how did we do it? The thing is that right now there is no large-scale data shape repository, like thinking of linked open vocabularies for ontologies. Something like that does not yet exist for data shapes. So what we did is that we looked into the SHACL specification, which is the shapes constraint language recommended by W3C, because it already lists a lot of different constraint types. And then we used the GitHub search and looked for the term SHACL in GitHub repositories and selected 19 repositories containing SHACL shapes, which do not appear as just simple examples. And what we did then is we defined for each constraint type of the SHACL specification like a definition in RDF using our Montolo Knowledge Graph. Then we used a lotstats extension to extract statistics from the input, in this case our GitHub SHACL shapes, to create statistics about constraint type use, which are described using our Montolo Knowledge Graph. And you can find the statistics online here under this URL. And they basically look like this. They are DataCube and Prof compliance statistics, where we describe different observations, whereas one observation, for instance here, describes one specific constraint type, then the actual measure which was taken, in this case the occurrence, so how often this restriction type occurs, and then also many other dimensions, such as when this measurement was taken, from which input it was taken, and so on and so forth. So the most interesting part now, what did we find and what does this mean for you? So we found that more than 60% of the 19 repositories define constraints for the basic structure of your knowledge graph. So the cardinalities of properties, the data types and classes of their values, or even like logical disjunctions, like it has to be either data type A or class B or whatever. And more than 30% of the repositories, so much less, use more specific constraints to really constrain specific values or something like regular expressions on literal values. and even less than 30% use other literal-based constraints or constraints regarding languages like English or for the labels, for example. So what does it mean now? It means that right now these kind of basic constraints for the basic structure seem to be the obvious choice: classes, data types, and so on. However, there are much more constraints possible and, for example, defined in the SHACL specification for a reason. So there's much more potentials to also use them, which are right now not used a lot. It also means that the tools we use right now to create and edit such constraints should maybe put a little bit more attention to these less used constraint types to avoid a self-fulfilling prophecy where they only provide us with class and data type constraints, which we then use in the end. So in this small talk, we looked into what constraints are, basically closed world restrictions for validation. We investigated the use of constraints to understand the use of different constraint types. And we analyzed SHACL shapes from GitHub using our Montolo framework. And we actually found that constraints for the basic structure are used a lot. And there's lots of unused potential for more detailed constraints. And going back to our initial question of if you would ride such a bike, well, you see, it's possible to ride a bike like that, but you don't have to if you just define your constraints to find really bikes with two wheels, which improves the quality of your knowledge graph. And also for developers, don't make it hard for users. You should support all constraint types. It should not be, as a user, not be harder to define, for example, a regular expression on a literal than just defining or constraining its data type. So stay safe.